Good morning. My name is Jerry Hovdestad. I'm the Director of COTS Engineering for Behlman Electronics. And my talk today is just to talk a little bit more about power supplies, and SOSA versus VPX power. VPX has been around a long time, maybe 8 years, and been providing power to all these VPX systems. The power levels have been growing, and they have been used pretty successfully now for the past few years. And SOSA, now using VPX, has decided to use a subset of VPX for their power. The idea to get more power and in the same size and make it more standard and more interchangeable. Anyway, the VPX 3U power supply, as it was in the past, it was envisioned to be about 500 watts, and there's lots of them out there. You can, on the slide here, you can see, they had inputs of 28, 48, 270, AC single phase, or with an extra card, three-phase input. You can't get three-phase on a 3U card by itself. The outputs, the pins will support up to 40 amps of 12 volts, 5 volts at 40 amps, 3.3 volts at 20 amps, an aux of up to 6 amps, and plus or minus 12 volt aux at 1.5 amps. Maximum power of 735 watts. There's not too much out there that will do that much power, and the dissipation on the card could get up to 100 watts. But that was the standard card. Okay, then we got the 6U VPX power supply, which again has the same inputs, 48, 28, 270, and on the card itself it will support single or three-phase AC. The standard card has outputs up to 80 amps on 12 volts. You can get up to 80 amps on the pins at 5 volts, 40 amps at 3.3 aux, and a plus or minus 12. The 6U card only has 5 outputs. The 3U card can have up to 6. There's no 3.3 volt on the standard 3U card. Now when we get to SOSA, they wanted to standardize it a little bit more. There's too many different combinations you can get with all of these outputs. So they decided on eliminate the 5 volts, eliminate the 3.3 volts, and you just have 12 volts. And you can get, on a SOSA card, you can get up to 80 amps. And on the 3.3 aux, you can get up to 20 amps. Not many systems quite need that much, but you can get that capability. If you multiply all of that out and add it up, you could get a possible capability of 1,000 watts on a 3U card. And with 140 watts of dissipation, there's not a lot of systems that can cool that kind of power, but it gives you more capability, and it gives you a standard. So if all the cards are only providing 12 volts and 3.3 aux, it makes it much more simple, much more interchangeable. More cards are interchangeable. And a colleague pointed out to me today that Intel put out a paper this year that Intel's commercial systems are going to be going 12 volt centric, so that everybody standardizing their systems on 12 volts seems to be becoming an industry standard. And SOSA is taking the VITA VPX spec and making it, it's using the 12 volt, or wants to use the 12 volt only system. In the 6U, there's been 12 volt only versions for a long time. For 8 years, there's been 12 volt centric versions defined by the VITA spec. There's been a standard version and a 12 volt centric version. The spec doesn't really need to change. SOSA is going to be using the 12 volt centric. You can actually you have pin capability to get up to 160 amps of 12 volt on a single card. There's not many supplies that'll do that. It would actually give you up to 2,000 watts on the card, and a 200 around at an 88 to 90% efficiency, you'd get a dissipation of up to 280 watts. So there's practical limitations in terms of cooling into using these cards, but the limiting the number of outputs is making it much more standard. The idea of having a standard like this is that it's much more interchangeable. There's many more, it makes it much more suitable for multiple people being able to supply the same card. And as you'll see probably in the interchangeability demonstrations, there's a lot of versions. There's Gen 1, Gen 2, Gen 3 versions of the card. You have a system and you can plug in any of the versions. It's giving the military the benefit of upgrading without having to requalify. You just have a standard card built to a standard spec. They decided to use VITA 62 as the basic spec, and they're getting the benefit of the interchangeability and upgradability right now. Future improvements, the 3U power could possibly approach 1,000 watts as people can get more and more 12-volt power. There are limits to the chassis in terms of cooling. You might need liquid cooling, or you might need to do other things in the chassis to handle that kind of power, but the power supply card has the capability of getting up to that power level. On the 6U card, again, power can approach maybe on a practical level 1,800 watts. You have plenty of power. You can get 160 amps. The connectors will handle 160 amps. There are problems with 28-volt input at low line because you start getting hundreds of amps of 28-volt current at these power levels. But at the 270 or AC currents, the input connector is not a limiting factor. Again, it depends on the system requirements, and what the input and output are. And SOSA is trying to take advantage of this extra power and the standardization to give them a benefit of making an easily standardized, upgradable power supply. In the future, cooling challenges. This was a slide from last year. Again, the existing standards, conduction cooled. Right now, the capabilities of cooling a conduction cooled, conduction to air is maybe 50 to 60 watts. Conduction to liquid, you maybe get 50 to 100 watts, 65 to 200 watts. When you start getting liquid in the chassis walls, liquid in the cover of the card, you can start getting up to the power levels that the cards are capable of. These will have to be taken advantage of in order to take advantage of the cards and power levels that are available today. Other things that are the one more difficult area is system management. Today, there's really no consistent standard for system management. Talking to smart power supplies. Power supplies are getting smarter and smarter. They can provide tremendous amount of system information. You can measure your voltages and currents and efficiencies and temperatures and everything. And the system managers, the systems can take advantage of that. And you have smarter and smarter systems. The systems can give you pre-warnings of possible failures. It can give you a lot of important information by taking the information that the power supplies can provide. However, if you have a power supply, you'd like to be able to interchange power supplies. Let's say Behlman isn't around anymore, and you'd like to be able to take another power supply and not have to spend a couple of years reprogramming some other system, some other language, some other set of commands and all of that. So we're trying to get a standard set of commands to define the address and the standard for input voltage, for input current, for output voltage and output current that doesn't exist right now. We're trying to get this standard set of commands and get the standards updated so that everybody does it the same way, so you have interchangeability. That's going to, that's an ongoing effort, and there's a lot of interest in it right now. In terms of taking advantage of the smarts, a lot of the systems are just starting to take advantage of it. I think you'll see, when you see some of the demonstrations later this week, some of the things that can be done. You'll see some smart systems, smart chassis. You'll see the kinds of information you can get out. And the idea is to standardize it so you get the same information out from anybody's card for the same just by interchanging the card, you won't have to reprogram or do anything drastic. The goals, SOSA goals for power supply management, again, create a common way of defining a SOSA interface. Cards now, we're looking at a standard 4611 dual IPMI, dual I2C interface, redundant interface, as defined in 4611, trying to follow the rules. The way it's set up, it looks like it can be followed. We just need to definitize the commands. You create a set of rules defining the minimum requirements. Not everybody's going to have all the features, but you want at least to have the power supplies to have a minimum set of features. And those need to be defined. It's all being discussed. Certainly, I think you want to know voltages and currents, probably temperatures, and there's work being done now to define those commands and identify the cases for data and how that data might be used in both lab development and production systems and operating systems. So if everybody knows what data they're getting, you can actually plan for it and use it in a constructive manner. The things that the intelligent power supply can do, again, it can report voltages, currents, output voltage, output currents, temperatures. You also have all inventory information, manufacturers, part numbers, serial numbers, revisions. So if there is something that goes wrong, you know the status of the power supply you have, the status and revision of your hardware, the status and revision of your software. It's all stored on the card. All of these functions are sort of defined in 4611. It could be different, however, right now, different depending on the manufacturer of the power supply. People can program it differently, have different commands, different addresses, and the supplies as they exist at the present time are not going to work the same. Once the standards are finalized, then hopefully everybody will have the same power, the same interchangeable power supplies, and you'll have the, again, advantage of interchangeability and upgradability. Some of the features like system reset and energy storage are other features that are, again, ambiguous or not quite defined in VITA. There's options, and SOSA is going to look to defining what should the system reset function be, what should the non-volatile memory interface function be. There's been a tremendous amount of discussion on that and how it should be handled, and it's really got to be definitized in the specification. Okay, SOSA updates, again, we're adding the 12-volt centric configuration for 3U. Keying is an important thing. As the one thing that people are going to realize, we see that people are buying now 12-volt centric cards, and they have a system that they've been using, and they would like to try out a 12-volt centric card. Hey, I'm going to try this now, and I'm going to get a lot of 12-volt power. And the problem is you can't plug in a 12-volt centric card into an old system because 12 volts comes out where 5 volts was. So if you have an old backplane, it's just not going to work. So some thought needs to be put into how are you going to handle the 12-volt cards with your existing system. There are a few workarounds, interim workarounds maybe for older systems, but the ideal thing is that the backplanes will be upgraded for the new system and everybody will have 12 volts hooked up where they need it. But as the people who are doing backplanes now, it's been obvious that it hasn't, people are not fully aware that they just can't plug in a SOSA card into a 12-volt backplane. You can, again, there are discussions ongoing as to how to do the upgrades, but it's something you have to be careful of. One way of handling that is the SOSA cards are keyed different, so you really can't plug it in if you key it right. That's a positive way of preventing somebody from plugging 12 volts in to a backplane that's looking for 5 volts still and blowing things up. So, again, we're looking to define system management and the capabilities and standardizing it. We're looking at clarifying various electrical, mechanical issues, make sure the new key positions are handled by the specifications, and there's editorial comments being incorporated. Upcoming related specifications, there's keying updates being done to VITA 46. I saw a final version, I think today, to review of a three-phase front-end card for the 3U. And there's ongoing work to finalize a VITA 62.2 270 volt DC connector for these applications. Okay, let's see, any questions?